So good morning to everyone. Thank you all of you for joining today our training sessions. Some of you know me. I'm Panayota Saradi from University of Patras, and we are project partner in the SEACAP for SDG project. And together, University of Patras, along with MEDREC, are organizing these training sessions in order to showcase the selecting reference projects that we have identified in the SEACAP for SDG project. And each project partner from the selected project will be able to showcase their outcome and train you in their methodology. In today's sessions, we have with us representatives from the Impulse project. So we are very happy for that, and thank you all of you that you are willing to join our training sessions today. And so maybe also Ms. Ferchichi for MEDREC will also have want to say a few words.
Good morning, everyone. Thank you, Panayota, for the introduction. I don't have anything specific to add. If I can just ask all the participants to add, besides their name, their institution where they come from, so we can know more about their institutions, participating institutions. And thank you, Sorina, for suggesting this. Thank you very much, and I hope this. Thank you, Vera, also for accepting our invitation to give a presentation on Impulse project outcome, and I hope this will be interesting for everyone. Thank you.
So thank you as well. As you know, today's session is dedicated to the Impulse project. We have a slight change in today's agenda. Because of the methodology and the information that we want to give you, the Impulse partners decided to present first the Impulse methodology booklet by Ms. Vera Valero, and then we will continue as planned with the Impulse preparatory set, the Impulse KPIs processor, and the Impulse financial sim. So the first presentation will be done by Ms. Vera Valero. Thank you very much for joining us, and let me know if you need any assistance during your presentation. I kindly ask all the other participants to mute their microphones in order to have a very well-organized session. Thank you very much.
Thank you for for inviting us to present our project results. I'm going to share my presentation now. Wait a moment, please. I think you can see it now.
Yes, you can see it.
Thank you. Okay, I'm going to present very briefly the methodology that was developed in the Impulse project that has been collected in the booklet. The Impulse project was a cooperation project from the InterRegMed program that it lasts 2.5 years. It ended in July 2019. And in the project, there were 10 partners involved, 6 local public administrations, 6 cities that implemented the methodology, and 4 partners with a technical role that developed the tools for the implementation of the methodology. The main objective of the project was to foster low carbon strategies and energy efficiency in Mediterranean public buildings. And the idea was to introduce an integrated management support system with the idea to help public administrations and municipalities to set reliable and affordable energy efficiency plans for the public building stock. Sorry. Later, there was we have just finished another the next step that was Impasse Plus project. Impasse Plus project was a capitalization project on the previous results of the project, and in this short project, we have also transferred the methodology to two new cities and to two regions, Emilia-Romagna and West Greece. But they, in a very short period, implemented the methodology from the beginning.
I'm sorry, Vera, I don't think that we are seeing your slides moving. I'm only seeing the first slide.
No, we're
Just me
seeing it.
or
It's okay. Maybe
you are seeing. It's just me then. I'm
sorry for the interruption there. Sorry.
You can see them moving.
From my side, we can see it, yes.
Yeah, we can.
Okay.
Yes, we can.
Okay, so I continue. Yeah, you have a video on the methodology that it's a very short video that only takes you 1 minute to see. It's quite interesting. I'm not going to play here because I think that you are not going to be able to listen it very well. But here you have the link, so you have the methodology presented in a very brief time. It's sorry. And I'm going to present the methodology with this slide. The Impulse methodology is developed in 4 main steps. The first step is the classification of the public building stock of a municipality or a region into typologies. So the idea is to group the buildings similar buildings into groups with similar characteristics. So we can consider that they perform more or less the same way. After that, the following step is that we select one ambassador building for each of these typologies. So we select one building that is representing all the buildings into the same group. And we call this building an ambassador building, and we simulate this building, and we perform an energy simulation survey for this specific building. And we extrapolate all this data to all buildings that belong to the same typology. The following steps is to we develop an energy renovation planning tool that is called KPIs processors plugin. So with this tool, you can the city can automatically build their own energy renovation plan for the public stock. And the following step, or the following tool, is the financial scheme tool, where the city can assess what is the best financial scheme for the financing of this renovation plan that they have set in the past. So according to these main 4 steps, we develop in the project some results, some tools that are represented in the left part of the slide, that are the ones that are going to be later presented by my colleagues from Impulse Project. And what we are going to present here is just a brief summary of the main step of the methodology that is collected in the booklet. The main results we got implementing the methodology and these steps are the ones that you see in the right part of the slide. So when you have the classification of the public building stock, and you have performed the energy surveys for all the buildings, you extrapolating all the data for all the building stock, you get at the end the energy saving potential of your public building stock. When implementing the energy renovation planning tool, you get the renovation plan for your own public building stock. And later, using the last tool, you will get the financial plan for this renovation plan that you have designed. You can follow the methodology in a very detailed way in the booklet. This is like it looks like. You have the links, I think you can find the links in the fact sheet, but you have also below. And in the booklet, the methodology is explained in 3 main sections that are 2.1, 2.2, and 2.3. Just to have a more detailed idea of what are the main steps and what you should do in following these steps. The first step is the classification of the public building stock into typologies. You will have to set the initial sample of buildings that you are going to work with. You have to set the public building stock of the municipality. So you have to collect for all the buildings the main information that are, for example, the building type or the building use of the building, the year of construction, the number of floors, the gross floor area, some information relating the construction types, what is the structure, for example, the envelopes. And you have also to collect what are the heating systems and the cooling system of this building. So once you have collect all this information for all the buildings, you will set what are the most relevant classification criteria. We will define what are the main classification criteria that you are going to use that are relevant in your case for the classification, and you have to set for these criteria the intervals you are going to work with. For example, below you can see this matrix. This is the example of one of the cities that implement the methodology in the Impulse project. So they decided, in the case, the classification criteria that they used were the year of construction, the number of floors, the type or the use of the building, and the surface of the building. So the intervals that they consider that they were representative in their case, for example, for the construction year was if the building was built before 1979, if the building was built between 1980 and 2006, and if it was built after 2006. The intervals were defined like this because it is linked with the thermal insulation legislation that applies in each year. So depending on when the building was built, we are considering that this building has been designed using a different thermal insulation law that was compulsory at this moment. So they at the end get the classification, the public building typologies that are represented there. And after that, they select one ambassador building for each typology, one building that is representing the buildings that are in this group. So you have to collect a very detailed information of each of these buildings. You have to characterize their envelope and to collect all the information regarding the systems of these buildings. The next step is to perform the energy simulation service for the ambassador buildings. You will, the idea is to use dynamic tools, and you can, in the Impulse projects, you have to simulate or to evaluate the base case scenario, the building as it is at the present, but you have also to simulate at least 4 retrofitting scenarios for a medium, deep, and zero energy building or a deep renovation stage. The idea is that you have to design these retrofitting scenarios considering that the energy measures that are implemented in each of them are correlated, that they are linked, so you can build by aggregating new measures to the ones that you have set in the previous energy renovation scenario. So, for example, in the medium, you can propose to improve, to change the lighting system, and in the medium, you will add new measures to the last ones that you have defined. There are some requirements for each of the renovation levels. You have all this information, it will be explained later, but you have also all this information very detailed, very well in the booklet itself. So I encourage you to download this publication and to read very carefully. You will need to calculate or to collect at least 33 indicators regarding energy performance indicators, environmental indicators, cost indicators, and also there are some comfort indicators that you can calculate. And later, the tool that you are going to use will enable you to prioritize what are the best renovation scenarios, and will help you to project the indicators to the building stock, to all the building stock according to the typologies that you have defined. The third step is the renovation planning tool, or the KPIs processors tool plugin. It's a tool, an Excel-based tool that works linked with the key performance indicator database that you have calculated in the previous step. In this tool, you will have to define from 1 up to 5 different indicators, and you have to give them some weight, And you can also define, or you can give positive or negative penalty for some special features, and you can select or not some of the typologies and scenarios that you want to consider to design your renovation plan. I think the tool will be shown later in a detailed way by Iya, so I'm not going to explain it very well here. And the last step is the financial scheme assessment tool. This tool analyzes two possible ways of financing the renovation plan that you have got from in the previous step. The first idea, if you can, is to take out that you can take out a loan at the start of the renovation plan for the total amount, for the total investment needed for the entire retrofitting plan. And the second option is that we are assessing is that if the public body takes out one loan each year per year over the duration of the renovation plan. So you have to introduce some data that comes directly from the renovation, from previous deliverables, or from the previous tools that you have been working with, like the key performance indicators processor tool or the plugin. You have also to introduce general hypotheses, that you are going to consider, you are going to estimate. And at the end, you have also to collect some information on the financial resources of the city regarding the public budget, the grants or subsidies, or other mechanisms that the city can access to. And you can compare the results from the different financing schemes against the energy bill baseline. That is the situation if you have not performed any of the renovations. You have graphical information and some tables also that are collecting all this information. And here I have put, you can find a link with to a publication, because if some of you are interested to work using the results or partially building on the results of previous cities that have been involved in the Impulse project, we guide you through this publication, and we help you to find which are what do you should be thinking on, and what are the information that you can take profit from. And this is all from my side. Thank you so much. I don't know if there are any questions.
Hello, thank you, Ms. Vera, for your presentation. This is Amjad Alkam from Ecosol. Can you hear me?
Yes,
Yeah.
I can hear you, of course.
Yes. I want to ask about if these tools, are they available only for this program, or they are open for the public?
No, they are all open for the public. You can find I have speak only about the booklet, that it is all the tools that we are going to explain today are open to the public, and you can download them from the Interreg Med deliverables, from the project deliverables database, and they are all public, so you can use them for free.
Very good, very good. And since we are new to this program with you in Jordan, can we ask if these tools, for example, were implemented in other similar countries before, and proved to be suitable to take into consideration the local situation or the local conditions?
Yes, of course. I think if we are going to implement the methodology from the beginning, there's not a limitation at all, because you can adapt the study to your own situation or to your own legislations and conditions. Okay, it is not like this if you want to build on the previous results of other cities, because you are limited by your legislation. But in the case that you are going to implement the methodology from the beginning, there is no restriction at all, because you are going to work or you are going to build depending on you are going to adapt the methodology to your own situation, to your local context. So there are no limitations at all. You will follow, or you will use the energy modeling programs that you have available in your country, that are that are recognized there in your country, and you will adapt the energy studies to your own legislation. You will follow your own legislation.
All right, thank you very much.
You're welcome.
Thank you very much. Is there another question for Vera, or should we proceed with the other presentations from Impulse, from Ms. Pakianaki and Ms. Hadjigeorgiou, and then gather all the relevant questions at the end of this first session? So let's continue with Ms. Pakianaki, Katerina Pakianaki, and Ms. Eleni Hadjigeorgiou from the Center of Renewable Energy Source and Saving in Greece. They're going to present us the Impulse preparatory setup and the Impulse KPIs processor. So the floor is yours.
Hello, everyone. I am Eleni Hadjigeorgiou from the Center of Renewable Energy Sources, CRES, in Greece. Just a second, I will share my screen. Can you see it in full screen?
It's not visible in full screen. We can see the presentation, but not in full screen.
I have it in full screen. I don't know why it's not showing. Just a second.
Now it is visible with full screen.
Okay. Okay, so I will speak to you about the impulse preparatory setup, and then my colleague Katerina Svakianaki will follow with some further tools of impulse. Sorry, it's taking a while to move the slides. Okay, first of all, just to say a few words about the role of CRES. CRES participated in 4 Interreg-Med modular projects in the previous period in the thematic of energy efficiency in public buildings. So we were the lead partner of the Impulse project and also a partner in projects Sherpa, Priority and SISMA, and an associated partner of the MEDNIS Horizontal project. And currently, CRES is a partner in the Horizontal Efficient Buildings project, which was effectively a follow-up of the previous horizontal project in the MED program, capitalizing on the results of all the 10 modular Interreg-Med projects in the thematic of energy efficiency in buildings. CRES is appointed by law as the National Coordinating Center in Greece for supporting the implementation of national policy for energy efficiency, including energy efficiency in buildings. It offers technical support to the ministry in matters relating to energy policy, but also to public entities at regional and local level for developing and implementing energy renovation plans and projects for public buildings. And also CRES is the national coordinator for the Covenant of Mayors in Greece. So I would like to add to the introduction that Ms. Vera Valero made earlier regarding the Impulse project, just to say a few words about what led to the development of this project, the drivers behind it, that it was on one hand, the demanding requirements of the European Union for public buildings energy renovations as were set out within the recent EU directives like the Energy Efficiency Directive, the Energy Performance of Buildings Directive, and their amendments, which set demanding requirements for nearly zero energy buildings for new buildings occupied and owned by public authorities from 2019, but also for existing buildings. They set measures to stimulate the transformation of existing buildings into nearly zero energy buildings. Also, there is a requirement for public buildings to play an exemplary role so that 3% of the floor area of public buildings above 250 square meters owned and occupied by central government are renovated annually. And also the directives encourage that public bodies at regional and local level follow this example of the central government. So they prepare energy efficiency action plans for public buildings under their authority and have a long-term gradual renovation plan. And also, besides the EU directives requirements, other initiatives like the Covenant of Mayors, there are plans that need to be made within the Sustainable Energy Action Plans, SEAPs, or the more recent SEACAPs. There are sections within that for the renovation of public buildings. So on one hand, it was these requirements, and on the other hand, it was the slow rate of actual building renovations taking place at local level, mainly due to the absence of technical data, the lack of specific methodologies to collect and organize information, the absence of reliable management support systems to map the building's energy performance and the cost-effective renovation measures, the limited resources of public authorities to develop these plans, and the lack of funding to access financial schemes for deep renovation. So these were the overall drivers that led to the Impulse project. And just to summarize the results that were achieved in total, for the 6 pilot cities that participated in the project, 6 libraries of public building typologies were developed, 1 integrated management support system for planning renovation projects in public buildings, including packages of cost-effective energy efficiency solutions that are replicable to other Med territories. 6 small-scale pilot renovation projects were implemented. 14 letters of intent were signed from public authorities at national, regional, and local level to further exploit the project outcomes, and 50 completed SEACAP sections on public buildings were achieved in Mediterranean municipalities. In Greece, more specifically, the pilot application included the development of an energy renovation plan for 76 municipal buildings of priority in the municipality of Heraklion in Crete. The total investment cost, the estimated investment cost for this plan was approximately 18 million euros, with an average estimated energy saving of 4.8 gigawatt hours primary energy saving for the duration of the plan, which was a long-term plan for a period of nearly 15 years. An estimated energy cost saving from the plan implementation of 250,000 euros, and a small-scale pilot project was completed, which was the energy retrofit of a school, the 7th primary school of Heraklion, where the lighting was replaced with LED lighting and compensation. Sorry. Weather compensation was added to the existing boiler system, leading to a 20% energy saving. So going back to the overall Impulse approach, the first steps of the approach include, first of all, gathering information of the public buildings of a municipality, then classifying these buildings into typologies, performing energy simulations for representative ambassador buildings. Then in the intermediate stage, from these energy simulations, key performance indicators, KPIs, are derived, which are then extrapolated to the entire building stock. And in the final stage, some small scale pilot renovation of projects in the 6 pilot cities were implemented, as well as monitoring of these projects using monitoring equipment. And also in the final stage, these results for each pilot city were depicted into GIS maps, making more user-friendly and illustrative the application, the results for the representative typologies and the energy efficiency measures. In parallel, various transfer and communication actions were implemented, meetings, training seminars, portability campaigns to further municipalities beyond the ones participating in Impulse. The overall methodology consisted of 3 main steps. First of all, the public buildings clustering into typologies, then the typologies energy analysis and development of KPIs, and finally the decision making for the gradual energy renovation plan. So this current output, which which was the title of this presentation, the preparatory setup for pilot activities implementation, was actually a deliverable of Impulse project, which you can find in the link below. All the deliverables and tools are available on the Impulse website. It's essentially a PDF document which summarizes the technical guidelines for conducting public buildings energy efficiency plans at local level. So it develops the whole methodology and steps that were developed by the Impulse project. First of all, for the classification of public building typologies in pilot cities, then how to undertake the typologies energy simulation surveys, typologies renovation planning and potential financing, pilot demonstration and monitoring projects, results integration into a web-based information system, then trial application of the Impulse system for SEACAP's development, and finally the evaluation of reliability, usefulness, and transferability. This slide summarizes the tools that the Impulse project developed in order to undertake this method, to implement this methodology. They are composed by a series of Excel tools. The first one, which is called Municipal Buildings Typologies Pilot City, is the tool which is used to record the information on the public building stock and to support the classification into typologies, and also the selection of a representative ambassador building per typology. Then what follows is the energy analysis of each ambassador building using either simplified or dynamic energy simulation tools, the analysis of the existing situation and energy renovation scenarios. And then all this information goes into the second tool, which is the KPIs Pilot City tool, which offers an automated way to prioritize the building typologies to renovate, but also within each typology, the buildings which should be in priority for renovation based on certain indicators. And the renovation scenarios also that should be prioritized: small scale, middle scale, major renovation or deep renovation. And based on this analysis, the tool also offers a projection of results across the entire building stock of the public authority. So it offers an estimate of the total investment cost and total energy saving that would be achieved if the entire building stock was renovated, depending on the scenario that is chosen as the preferred scenario. And finally, the last tool, the plugin tool, supports the development of a long-term energy renovation plan for the public building stock based on the selection parameters from the user for the buildings that would be renovated each year, or the percentage floor area, the degree of renovation. So after making some selections, this tool helps you to develop a long-term renovation plan. So I will focus now only just on the first step of this process, on the first tool, and then my colleague will follow on with the second tool. The classification of public buildings into typologies in the pilot cities. There are 5 steps in this process. First of all, is to determine the initial sample of buildings that will be used for this analysis, then to collect information for this sample of buildings, to determine the building's classification criteria, and then to classify the buildings into representative public building typologies based on the adopted criteria, and finally to identify an ambassador building, one per typology. This process with these steps leads to creating a library of municipal building typologies, and in the project Impulse, 6 such libraries are already developed and completed, and you can find them as results in the project website for the 6 pilot cities. So the first step to determine the initial testing sample of public buildings, the impulse methodology recommended that a minimum of 70 municipal buildings, depending of course on the size of the municipality. In the 6 pilot cities that were studied, the range of public buildings were between 100 and 400. So in this case, it was recommended to collect information for a minimum of 70 buildings. The buildings of the sample should be fully accessible with full technical information, drawing system details, etc., and also be accessible for experts to visit them to collect the necessary data. In the sample, we should include building types or uses of top priority for energy renovation. At least 2 building types should be included, the ones that are the most frequent in the city. And also we should ensure adequate diversity among buildings of the sample regarding their key characteristics. So number of floors, age, floor area, etc. So after we determine the initial sample of buildings that we want to further analyze, information should be collected for these buildings, as much as possible information for the key characteristics, the building name, the floor area, the address, the year of construction, number of floors. Also, any information that is available, such as whether there's already an energy performance certificate, an energy audit, whether there are building drawings in digital format. And all this information is recorded using the first impulse tool, which I will show you in a moment. Then the next step, the next 2 steps are essentially the determination of the building's classification criteria into typologies and the actual classification. So it was decided for the impulse methodology that these 7 are the main criteria that municipalities could use for the classification. So the building type used, the year of construction, the number of floors, the floor area, the construction type, the heating system, and the cooling system. And from these, at least 4 criteria should be selected, including the key one, which is the building type, reflecting the specificities of the public building stock in the assessed territory. So each pilot territory may have selected a different classification criteria depending on the characteristics of the building stock. And also for each of these criteria, specific ranges, intervals should be adopted. So for example, in Greece, where we have a key moment in the legislation, in the energy legislation, which was 1980. Before that, there was no requirement for thermal insulation in buildings, for example. So the first insulation regulation started after 1980. So we have as a key milestone buildings constructed before 1980 and after 1980. Then the second milestone is the first introduction of the building energy efficiency regulations, which was 2010. And then the updated regulations in 2017. So for selecting the intervals in the year of construction, for example, we selected based on that. So buildings before 1980, then buildings between 1980 2010, and then buildings between 2010 2017, etc. So each municipality, depending on the specific context and priorities, should decide on the intervals that would be applied for each of these criteria, depending on the building stock. And then finally, after determining the main typologies, one ambassador building was identified as the representative building of each typology. It should be the one with the maximum availability of technical information, drawings, construction characteristics, heating and cooling system properties. Because this building, in the next stage of the process, we studied the ambassador buildings using dynamic energy simulation. So in order to study these buildings, we should have as much as possible all the technical information available. And also it should be a building that adequately represents all the buildings belonging to the same typology. So this slide just summarizes again the methodology that first of all, we have various methods of data collection, interviews with the energy managers of the buildings, questionnaires, physical site visits, observation to the building, databases. So we collect data for these buildings. We decide on the intervals for the classification criteria, like the building types, offices, schools, others, and then within each of that building type, further subdivisions into construction years or numbers of floors or construction types. And this leads to the determination of the public building typologies. So one typology is not enough to say that all school buildings are one typology, because you may have school buildings constructed before a certain year with certain construction characteristics. So the typology definition for the purposes of the Impulse project was combined a combination of several criteria and subdivisions of criteria. And then finally, the selection of ambassador buildings. For each ambassador building, as I said, more detailed information was collected and also recorded into the Impulse tools. So the tool that supports all what I have explained in these slides is available on the Impulse website. It's called Municipal Building Typologies Pilot City. And also there are completed examples for the pilot cities that we undertook during the implementation of Impulse. For example, the Greek city of Heraklion. And then I will now go to open the tool to show you a little bit how it works. So it is an Excel tool which includes various tabs. Okay, the first tab is the cover page. The tool is called Listing Public Buildings, Classification into Typologies and Corresponding Representative Buildings. There are some instructions on how to use this tool. So there are detailed instructions for each column and what kind of information should be completed. The cover page. And now this is the first tab that actually shows the list of public buildings that are collected by the municipality. First of all, just to say that I have opened the completed example for the Heraklion city, but these tools are available empty, blank for you to use on the Impulse website. So here we can see the list of buildings that were collected by the Heraklion municipality. So in total, they collected a sample of 84 buildings out of a total building stock of over 200 buildings. So the first column is the building name, then the building address, the GPS coordinates. I don't know if you can see, or is it too small on the screen? I will just make it a bit bigger.
It is okay. It's okay.
That's better, thank you.
Okay, so the building coordinates, then there is a column on the building type use. For each of these columns, there are some drop-down menus which are created depending on the specificities of each municipality. So at the end of this spreadsheet, in the last tab, you can create your own drop-down menus. Including the, for example, the building uses that you plan to include. In this case, we had 13 building uses: educational buildings, offices, health and social care buildings, museum, libraries, residential for communities, etc. Then here also the intervals for each classification criteria are created. So these are created by the user depending on the specificities of the building stock. So here we had buildings before 1980 and between 1980 and 2010, for example, in the construction year. In the number of floors, we had buildings below 2 floors and buildings between 3 and 5 floors. In the gross floor area, we have buildings below 1,200 square meters and buildings between 1,200 and 4,000 square meters. And the same is done for all the 7 classification criteria. So some ranges are created here in the drop-down menus, which then you can use when you go back to your main Excel sheet and select here for each listed building, what is the building use type, what is the construction year, the number of floors, the gross floor area. Sorry, in this first Excel, actually you record the absolute values and then you classify into ranges. In this first tab, you just record the information as it is. So the floor area of the building, the roof geometry, for example, whether it's a flat roof or an inclined roof, the roof material, the structure, whether it's a lightweight, medium weight, heavyweight structure, the type of envelope, whether there's insulation in the envelope, the type of glazing, single glazing, double glazing, the window frame material, the heating system. Here they had oil boilers or local heat pumps, and the cooling system. Whether there is air conditioning, what type of air conditioning, or no air conditioning. So in this first tab, all this information is recorded for all the buildings that were decided to be in the sample. And then in the second tab, we again have a list of these buildings. But then here also you have listed all the 7 classification criteria that the municipality decided to use. Here you decide each of these buildings into which range of classification criteria it belongs. So the first criteria was the building type used, then the construction year. So here you have the ranges. After you have already selected the ranges you would like to apply, here you say that this building, which may have been constructed in 1990, belongs to this range of 1980 to 2010. Or the next building is constructed before 1980. So here actually you apply the ranges of criteria that you have already decided. For example, the number of floors, you have either buildings below 2 floors or buildings between 3 and 5 floors. The same for the floor area, the construction type, the heating and the cooling system. So whereas the previous tab was the actual, the absolute values, here you have the ranges of values that have been specified. And this leads to the third tab, which helps to classify all these buildings into representative typologies. So for example, here, for the municipality of Heraklion, it was derived that there are 10 representative typologies, and then the ones below in red were some buildings where there was only one building, for example, for one typology. So these are not considered representative and were not used in the end because we didn't want to have a whole typology being represented by only one building. So the typologies that are the most frequent were actually 10. The first typology, for example, was, just make it a bit bigger. it was a combination of these criteria. So it was buildings of educational use that were constructed in the period between 1980 and 2010 that were below 2 floors, below 1,200 square meters, medium weight construction. They were using an oil boiler, and they had no or very limited air conditioning. So the combination of all these 7 criteria led to the first typology. The second typology were also educational buildings. Actually, in the municipality of Heraklion, the majority of the buildings that were selected in the sample were educational buildings. It's just that they had different characteristics. That's why they were classified into different typologies. So here in the second typology, we can see that all the buildings were using a heat pump, for example, for air conditioning, which is why this was considered a second typology different to the previous one. Then the third typology, it was buildings also using a heat pump for conditioning and an oil boiler for heating, but they were all between 3 and 5 floors, whereas the previous ones were all below 2 floors. So these were again a different typology. And then the fourth typology was different because it was a different structure. So it was heavyweight construction compared to medium weight, which was the previous ones. And also they had no air conditioning. So there are subdivisions of these criteria that can lead to the development of one typology. So we can see here, for example, that we had 5 buildings of this typology number 4. The fifth typology was buildings between 3 and 5 floors, again educational, with medium or heavyweight construction with an oil boiler and heat pump. So this is the way that using the various combinations of these criteria that the buildings were categorized. And finally, we have a final typology which was not educational buildings, it was health and social care buildings, with 2 buildings in this category, which formed a final typology number 10. So depending on each municipality and the type of building stock that you have, then the intermediate ranges in the criteria, this process can be undertaken. Then after we finalize the typologies, one representative building for each of these typologies was selected to be the ambassador building. So for example, for public building typology number 1, the ambassador was elected to be a specific primary school, the 19th primary school, where using this next Excel tab, all the information that was available for this building was collected and recorded here. So all its basic characteristics, as well as photographs, information on the building envelope, the external walls construction, the exposed floors, the windows, the type of windows, the U values of the windows, the building services information, the types of heating systems, which in this case were more than one. So it was a central boiler, but also a local heat pump, the types of cooling system. So again, here we had more than one type of local heat pumps with different efficiencies. So here it was a detailed collection after site visits in this ambassador building to collect as much information as possible, which would then be used to do the energy analysis of this building using simulation software. The same for ambassador of public building typology number 2, which was again a school. So in the same way, there are here different tabs for the 10 ambassador buildings that were selected in the specific case in the municipality of Heraklion, and information that was collected for each of these buildings and recorded using this tool. here in the end, there is also a tab that shows all the drawings that were collected for each of these ambassador buildings, the drawings that were available in digital format. But essentially all the information is summarized in these tabs. So this is an overview of this tool, of this first tool that undertakes the classification of the buildings and the selection of ambassador buildings. You can find it, as I said, empty without being completed on the Impulse website, so you can try using it with your own buildings of interest. Thank you for your attention, and my colleague Katerina Svakianaki will follow with the next tools of the methodology of Impulse.
Thank you very much, Ms. Hadjigeorgiou. Since the next presentation is also about Impulse, so we have a few questions now regarding this tool, and then gather the information for the other tool as well.
Yes, of course, if there are any questions, yes.
Yes, one question before we proceed with with Ms. Svakianaki's presentation. You mentioned that the classification criteria were decided by the municipality. Is that correct?
Well, no, the Impulse methodology developed a set of classification criteria, but it is recommended that the municipality out of these criteria selects at least 4 that are the most appropriate depending on their local context.
So in the case of Iraklio, 4 criteria
in
were
the case
selected.
of Iraklio, they selected all the 7 criteria
All
that
the
are
7.
on the list. Yeah.
But there were cases in other pilot sites that different criteria were selected. That's what was my question, that you had either pilot cases in different countries, etc., that used different criteria from this Iraklio.
No, it was not different. It was just perhaps not all the 7 ones. It was the same list of criteria because it had to be a common methodology that was developed. It's just within each criteria, each pilot city could select the ranges or intervals that were more suitable for their cases. So for the criterion year of construction, we had different years of construction in Greece in Iraklio, and different years that were selected by other pilot cities as the milestones. But the criteria was year of construction, it was the same.
Yes, of course. But in your opinion, based on the project outcomes, what was one of the, you mentioned that each municipality had the option to select up to 4, not up to 4, at least 4 criteria.
Yes.
What were the most common ones, as to say, not the common ones used with more frequency? Like the year, as you mentioned, was one of the
yes, the year,
options.
the floor area, and the building type are the most common because these are the ones you have usually the most information for. The number of floors also, the building systems and construction type are more difficult to have information, detailed information. So.
So based on this,
typically it's the year, the floor area, the number of floors.
Yes. So thank you very much for your question, for your answer. So if is there any other question for Ms. Hadjigeorgiou?
Yes, thank you very much. I want to ask about, for example, in the municipality that the example municipality that you showed to us in the examples, these buildings like the schools and the other buildings are all of them under the responsibility of the municipality, or we consider them in our project regardless if they are under other not under the municipality responsibility. Like for example, in Jordan, we have the Ministry of Education is responsible for the schools. The Ministry of Health responsible for the hospitals. So the municipality has maybe no responsibility about these buildings, or the nature of the project is to consider these buildings just within the municipality area.
Well, the ultimate purpose of all this process is to develop a gradual energy renovation plan for the building. So the
Yes.
idea was to be buildings that are within the administrative authority of the municipality, so that the municipality can apply some interventions to them. So in Greece, yes, it was buildings that were owned by the municipality, the educational buildings. There are also here some requirements that the Ministry of Education has some specific specifications for doing interventions in schools, but these buildings belong to the administrative authority of the municipality, so that's why they were included in the plan. So yes, we recommend that you include the buildings that are under the municipality's jurisdiction, so that later on you can say that you will apply some energy saving measures to them. That's the whole purpose of the plan, so that you develop the cost for these measures, the energy savings for these measures. Otherwise, of course, you may include buildings that are not that are just within your territory, but then you should collaborate with the other authorities to for the actual implementation of any such project, if these buildings are not owned by the municipality.
Thank you. Thank you very much. Thank you very much.
Is there another question for Ms. Hadjigeorgiou?
Hello, can you hear me?
Yes.
Hello,
Hello.
This is George Stavrakakis from MES Energy. We are the subcontractor of University of Patras, and the plan is that we will understand as better as we can the tools provided in order to test them and capitalize them in selected municipalities here in Greece. So what I'm trying to understand is that okay, if a municipality or a region requires to do energy renovation on specific buildings, the answer is that they already have the know-how to design and devise all the technical detailed studies in order to perform this kind of energy renovations. So my question is, what exactly is the benefit of having this kind of renovation plan, and what is the key delivery, let's say, of the Impulse project? I mean, why someone it is recommended to use it?
Hello, George. I will just say that the benefit will be more obvious after Katerina presents the following tools also of Impulse. That the benefit is that with analysis on only certain buildings of the building stock, one can extrapolate and have a relatively quick and reliable energy renovation plan for the entire building stock without analyzing actually the entire building stock. But this is undertaken using the following tool, which Katerina will present. This first tool just serves to do the classification of the buildings into the representative typologies.
Okay, so the main...
If I answered you of the question.
Yes, perfectly. So if I understand correct, the main benefit is that on the basis of a very good classification of buildings, we could rely on the projection of some ambassador buildings of the KPIs to the rest of the building stock, so we can develop in a more easy and a comprehensive way a reliable energy renovation plan. I'm asking that because right now in Greece, the very hot spot area is a specific funding mechanism recently introduced that specifically requires from municipality to submit their energy renovation plans in order to get funding. And through these renovation plans, they should demonstrate why these buildings are selected for renovation. I mean, the funding program is to renovate, let's say, up to three buildings or 4 buildings or 5 buildings. But the municipality shall justify why these buildings are selected. So the opportunity of Impulse project is to run away from this kind of selection. I don't know if you can look at me. I want this building or this building or this building or another building, and have a coordinated way to prioritize which are the best buildings to proceed to renovation. So for us, at least in Greece, I don't know if Panagiotas Aradi agrees, it's very hot, these tools, and for sure we will promote them.
Thank you very much, Mrs. Stavrakakis. Of course, we at the University of Patras have also studied this area and how we should proceed with outcomes selected and what we can do with them in order to also improve the situation regarding our selected municipality in the SEACAP for SDG project. So at this time, I think we should proceed with Mrs. Pakianaki's presentation and then gather any more questions we have regarding these impulse tools in order to continue. Thank you very much. Mrs. Pakianaki, the floor is yours.
Thank you very much. Good morning to all of you. Thank you that you invite us to this training event in order to present impulse outputs, which we believe that they are very useful. So I will follow Mrs. Hadjigeorgiou presentation. I will share my screen. Okay, now you can see my screen, full screen.
Yes, thank you.
Yes.
Okay, thank you very much. So, as my colleagues said before, Impulse is a project of IDEREG-MED program that tried to introduce a management support system for local and regional authorities in order to be able to plan reliable and affordable energy renovation projects. And at this point, my presentation has to do with the definition of some key performance indicators, energy, environmental, and cost indicators that are related to public building stock in each case, and how this definition help support municipalities and in general authorities in order to plan energy renovation projects. So at this slide, you can see impulse methodology in general. So you can see that we have the first step that Mrs. Hadjigeorgiou described earlier about buildings classification. Mrs. Hadjigeorgiou described in detail that we tried to categorize, to have buildings typologies And for each one of these typologies, to have one building that was the ambassador building for each category. Then the second step has to do with energy simulation and the developing of protocols. Excuse me, can you hear me?
Can you please mute your mics, everyone, so Ms. Katarina can speak clearly?
Okay, thank you. So the second step, as I said, is the definition of key performance indicators through energy simulation and monitoring protocols. And at the final step, these key performance indicators were put in a GIS system where we could see the key performance indicator for each one of the public buildings. And these pictures that you can see in the slide, they are taken from one of the pilot city chosen in the framework of Impulse project. So for all the ambassador buildings, we have first the base case scenario. And when we say base case scenario, we mean the current situation. How are the buildings now at the current situation? And we calculated energy performance indicators, environmental indicators, and cost indicators. You can see in the picture how is the XLS platform, a part of the XLS platform. We have the opportunity later to see these platforms in detail. So our first step was to record all the data regarding the base case scenario. And then we decided to run simulations about the energy renovation scenarios. We have scenarios regarding minor retrofit, medium retrofit, major, and deep renovation. What are these scenarios in more detail? When we say minor retrofit, we mean that we have in these buildings renovation that is up to 35,000 euros, and the reduction of energy performance indicator is higher than 15%. When we discuss about medium retrofit, we discuss about a renovation up to 100,000 euros and the reduction of total primary energy higher than 25%. Regarding major retrofit, we have the minimum energy performance requirements that national legislation sets. And regarding deep renovation, we have the interventions that in major retrofit are proposed, plus the integration of renewable energy systems. And here in this slide, you can see the scenarios tested in more detail. You can see the three categories: small scale renovation, medium and large scale renovation, and deep renovation. So in the first category of scenarios, small scale renovation, we have the following interventions: thermal insulation of roof apartment, compensation system controller and thermostatic valves that has to do with the heating system, replacement of lighting fixtures with LED, and sensors for detecting presence or level of lighting. Regarding medium and large scale scenarios, we have thermal insulation of horizontal and vertical structural elements, replacement of window and door frames, and also replacement of air conditioning system, cooling and heating. And finally, in the deep renovation, we have replacement of air conditioning system and installation of renewable energy systems, in most cases, photovoltaic systems. So as you can see in this slide, we have a gradual renovation module. That means that we start with some measures that are how to say, are in a small scale renovation scenario, and at the end we put the renewable energy systems. So at the beginning we are trying to improve the buildings, to improve the building cell, and then we try to cover the energy needs or part of the energy needs with the renewable energy systems installation. For each one of these renovation scenarios, we also calculated the energy performance indicators, the environmental indicators, and the cost indicators. So in the same platform, we have, as you can see in this slide, the definition of key performance indicator for all the scenarios: the base case, the minor retrofit, the medium retrofit, the major and the retrofit at the deep renovation scenario. And this is the first thing that we achieved. We achieved in one unique platform that we have all the key performance indicator of all ambassador buildings for the base case and for all retrofit scenarios. And this is very important to say, because if some of us, we are engaged in projects in collaboration with local or regional authorities, we know that it is very difficult for them if they have a large building stock, to have one base, to have one platform where all the buildings are recorded, all the performance indicators are recorded for the base case scenario and also for some renovation scenarios. This is the beginning, and this will help us to the next steps. Here in this slide, you can see a part of this platform that we have the opportunity to see it later in detail. You can see that we have all the ambassador buildings, all the representative buildings of each typology, and for each one of them, we have the cells to be completed regarding the energy performance indicator, the environmental indicators, and the cost indicators. So, what is the first advantage of this methodology? The first advantage is that we are based on the analysis for the ambassador buildings, and we can extrapolate our results to all the building stock. So, if, for example, a municipality has 100 buildings, we can analyze the performance indicators only for the ambassador buildings, and then these platforms help us to extrapolate our results to all the building stock. The same results are extrapolated from one building to 8 or 10 buildings. And this is our first advantage. The second advantage. The second advantage is that we can, through this platform, prioritize the energy renovation scenarios that we are going to proceed. What this means? We have one building, and the mayor of the city wants to proceed with the energy renovation. According to this platform, we have the opportunity to have a reference cost indicator, which is the total investment cost per total annual energy saved. As you can see in this slide, for example, regarding Ambassador Building 1, excuse me for a moment. Regarding Ambassador Building 1, you can see the reference cost indicator is calculated for minor retrofit, medium retrofit, and major retrofit scenario. And you can see these values. So the lower is the value, the best is for the investment. That means that in this slide, regarding Ambassador Building 1, we have a lower value for scenario 3 in minor retrofit. So we can propose this scenario to be implemented as it has the lower reference cost indicator. This intervention will have as a result low cost and high energy saved. So it is preferable to proceed with a minor retrofit scenario in this case, in this Ambassador Building 1. So we have the opportunity to choose not only because we want to renovate, but because we have calculations, we have specific reference cost indicators. And of course, the other advantage is that we can prioritize the buildings in terms of investment cost and energy savings. That means that if we have, as in this example, 10 public buildings, and we have for each scenario the calculation of reference cost indicators, we can choose this building that has the lower reference cost indicator. In this case, as you can see in the slide, and if I'm not wrong, the lower value is for Ambassador Building 10. This means that it is best for the municipality to choose first renovate Building 10, and then regarding the values of these indicators to proceed with the other renovations. So we have a prioritization of buildings and the prioritization of scenarios. And always this is done in terms of investment cost and energy savings. Here in this slide, you can see another example. We have for minor retrofit scenarios the reference cost indicators calculated for 3 different scenarios and for all the Ambassador buildings. And we can see, for example, regarding scenario 1, we have a very high value for Ambassador Building 1. That means that it is not recommended to proceed with energy renovation for this building. And also we can see that we have a lower value for Building 10. And of course, we can see for the same building, different values of this indicator for the 3 different scenarios. And you can see that there is a big difference between, for example, scenario 1 and scenario 3. You can see a value of 1770 for scenario 3. That means that this scenario is not recommended for this specific Ambassador building. So as Mrs. Hadjigeorgiou told before, the tools are available in Impulse website. And here in this link, you can find the XLS platform for the definition of these key performance indicators per typology and per retrofit scenario. And of course, in this link, we chose an example, the example of municipality of Heraklion. Heraklion is one of the 6 pilot cities that used these platforms in the framework of Impulse project. So you can see also the example where the data are recorded in the XLS platform. And of course, now we are ready to explore this XLS platform in order to show you in detail the content. So this is the KPIs processing tool, prioritizing building typologies and retrofit scenarios and extrapolating KPIs to the entire building stock of communities. Here are some general instructions regarding the use of this tool.
I'm sorry for interrupting. Could you zoom in a little bit more?
Yes, of course.
The Excel file to be more visible. Thank you.
Now it is better?
Yes, much better. Thank you.
Okay, so here you can see some general instructions on the use of this XLS platform. It has some details regarding the objective. We can calculate through this tool a key performance indicator and of course prioritize retrofit scenarios of each ambassador building and prioritize the ambassador buildings that we suggest to be retrofit. And at this sheet, we can insert the name of the city that will complete the data. I will zoom in also. Okay, excuse me, one moment. Okay, and at this point, we have the base case sheet, which has the energy performance indicator, which are total annual primary energy consumption, annual final energy consumption for space heating, for space cooling, annual final energy consumption for domestic hot water, for lighting, electricity consumption, consumption of fossil fuel, annual generation of renewable energy, and energy class if it is exists from the certificates. And you can put in these cells the values for these energy performance indicators for all the ambassador buildings, for the buildings that you chose that we are very representative and you have a lot of data of each one building category. Then we have some environmental indicators like the total annual CO2 emissions, the annual CO2 emissions from electricity consumption, the annual CO2 emissions from fossil fuels consumption. And finally, we have cost indicators the annual total energy related operational cost, the annual electricity cost, the annual fossil fuel cost. This is for the base case scenario. And then for each one of the retrofit scenario, we calculate the same values, energy performance indicators, environmental indicators, and cost indicators for each one of the scenarios for minor retrofit, medium retrofit, major retrofit, deep retrofit. Here is the minor retrofit part, medium retrofit, major retrofit. And deep. In case of Impulse project, these values were calculated through energy simulations. In each case of municipality that wants to proceed with these platforms, the values could be reached not only by energy simulations, but also by using another tools or by using data that are recording from bills, etc. So here we have the prioritization, as I saw in the slide before. We have the ranking of buildings for all ambassador buildings for each one of the scenarios. And the other is that we have the projection for all buildings that belong in the same category that the ambassador building is. So we have a projection for all buildings of the municipality based on the results from the ambassador buildings for base case scenario, for minor retrofit, medium retrofit, major retrofit, and deep retrofit. So at this point, I think it is better to show you the XLS platform for Heraklion. So at this case, you can see for each one of the ambassador buildings, for example, for ambassador building 1, 19th primary school, all the performance indicators were recorded for energy, for environmental, and cost, and the same for minor retrofit scenarios. We can see the annual primary energy consumption, the final energy consumption, the energy consumption for cooling, for heating, for domestic hot water, and the same for medium retrofit, major retrofit, and deep retrofit. And then I will focus in this slide about prioritization. We have the ranking of buildings regarding this referent cost indicator, which is the total investment cost per total annual energy saved. And we have values from, as you can see, from 1 to 23. And this is an issue to decide from which building we will start. We can see that the lower value is for ambassador building 10, and the higher value is for ambassador building 1. That means that we prefer to proceed with buildings that have low values in this referent cost indicator and not with these buildings that have high values. The same for medium retrofit, major retrofit, and deep retrofit. And of course, here you can see the huge database we have for all the public building stock of municipality of Iraklio, the energy performance indicators for the whole building stock based on the ambassador buildings. For base case scenario, for minor retrofit, medium retrofit, major retrofit, and deep renovation. So I think that it is a little tiring to explore these all XLS file. I believe that it is better for you to download these files. They are available in our website, and to have the opportunity to see yourselves the advantages of these tools. As I said at the beginning of my presentation, the main advantages of these platforms are, first of all, that we have the possibility to have all our data in one XLS. And the other very important thing is that we can prioritize the buildings that will be renovated, and also the renovation scenarios that we will be very effective for our renovation plans. So this was from me. Thank you very much for your attention. And of course, we can discuss now and answer in any questions you have.
Can you hear me?
Yes.
I can hear you.
Hello, my name is Dimitris Ziritas and I work at MES Energy, which is a subcontractor of the University of Patras. So I would like to ask a question on the methodology. So from what I understand, the extrapolation that is done based on the ambassador building is based on the assumption that building of the same typology have similar indicators like energy consumption and so on. And I would like to ask, is there any validation on the accuracy of this assumption? And for example, if when working with the buildings, when someone defines, for example, only 4 typologies or 3 typologies because there are no available data, is this assumption still accurate enough?
If I understand well, your question is how we know that if we have some specific energy savings for the ambassador buildings, we know that the same energy savings are
Exactly.
for the buildings that belong to the same category.
Exactly.
For us, in case of our pilot cities, we assumed this because the buildings of the same typology have almost the same characteristics. That means that have the same insulation, the same glazing, the same. So when you simulate, you can assume with quite high percentages of success that you have the same results to the buildings that belong to the same category. I think that the key in this situation is the first step, the step of categorization. Of course, it is not an easy issue to have buildings and to categorize them in the same typology. We all know that in case of Mediterranean countries, we have buildings that differ a lot. But I think that if we do a very analytical job at the beginning to have the first categories of building and choose one building with a lot of data, with a lot of data concerning energy, we can assume that the same situation, the energy saving percentages will be the same for all the stock of this category. I don't know if Mrs. Hadjigeorgiou, who is fully involved in energy simulation, can add something about this.
No, I agree with what Katerina just said, that it is important to focus on the first step and do a good work in the categorization of in the classification criteria that will be selected for the typologies. So as we described earlier, it is not sufficient to just say that all school buildings, for example, are one typology, but one needs to define sub criteria within that. So all school buildings built before a certain year with certain construction characteristics. So as much as possible, the more criteria you select to specify the typology, obviously the better the possibilities that the buildings that belong to this combination of criteria will have more similar characteristics. Also, all the indicators are derived obviously per square meter. So all the energy consumption indicators are per square meter of building. So then you extrapolate. So buildings of very similar characteristics are quite likely to have similar per square meter indicators. But of course, yes, there are always buildings that will not fall within any of the specified typologies, but it depends also how many these are in relation to the overall building stock and whether these can really make a significant difference to the overall plan. As regards the validation, sorry, the fact that the methodology was implemented in 6 pilot cities, and there are completed examples of quite a diverse range of building stock in the 6 cities in Spain, in France, Greece, in Bosnia and Herzegovina. So there are quite there's quite a diverse range that these tools were used in terms of type of building stock and types of buildings, and these were found to be quite representative as a methodology.
Okay, thank you very much. This is clear.
If I may ask one question also. Thank you, Katerina, for your presentation. I am Suhaib Shishi, partner of SEACAP project from Tunisia. I wanted to ask about the climatic conditions in order to understand if we can apply the tool in the southern shore of the Mediterranean. So do you have, for example, a database of climatic conditions covering different countries other than the ones you worked on? Or, for example, if we have the climatic conditions for one specific country, can we introduce it in your tool, and how can you do
that? These tools have not something regarding climatic conditions. That means that energy simulations were performed. Energy simulations took into account the climatic condition of each pilot city. So we have results from specific cities in specific climatic conditions. But these were taken into account in the energy simulations. So if you want to use these tools in different climatic conditions, you have first of all the choice regarding base case scenario to record data from bills, from data from the municipalities, and then you have to calculate the energy renovation scenarios results through energy simulations or or by using the tool, but assuming different climatic conditions. This is something that Impulse Plus investigates. Impulse Plus is a project that use this methodology, but in case of different cities. So I don't know if Vera can answer on this field, or MES Energy can answer in this field, which work on this, how we can, other cities from other countries can use the same tool, taking into account its climatic conditions. I don't know, Vera, can you hear us? Because I know that in case of Impulse Plus, there are other regions. For example, in Greece, we have the example of city of Heraklion, but Impulse Plus works for another city, which is in the north side of Greece. And I know that they tried to transform these tools to another climatic conditions.
Thank you. I can write to Vera to ask her if she's
Yes,
not.
yes, okay.
Thank you very much.
Can I just add something regarding that question?
Yes, yes, George.
So as far as I understand, the Excel-based tools rely on a simulated ambassador building. Am I right?
Yes.
So that means that the simulated ambassador buildings have already been done in a simulator, in a simulating environment, having already imposed the climatic conditions. So that means that the projected results to the other buildings of the same typology already rely on simulated energy performance of a building based on the climatic time series for which the ambassador building is analyzed, is simulated. So from that point of view, I think that the Excel tools, I suspect that they are not affected in the way they operate. Of course, they are affected regarding the ambassador buildings that when the KPIs are projected, but not in the Excel tools per se. I mean, the climatic conditions have been already imposed in an external simulator for only the ambassador building. So we got for that climatic conditions, we got the time series of KPIs, and they are extrapolated. Now, if we want, of course, to cover all the climatic zones of a whole country, then ideally, if we perform, for example, a country-based plan, ideally another classification criteria should be the climatic zone, when we develop the typologies. However, because as far as I understand, the impulse tools were introduced to be applied at local level, at this point, they do not include this as a classification criteria. But if they are ought to be applied for a country plan, then another classification criteria should be added to include the climatic zone. I don't know if this idea is correct.
Well, if I may, this is, of course, my name is not Toshiba. My name is Sadak Gelouz. I'm from Tunisia. I'm working with, as an expert with Medrek on this project. I totally agree with Mr. Stavrakakis. I don't think Impulse has anything I mean, that would change with the climate. So the climate, if you wish, influence comes through the simulation of the building. So I think Impulse can be used for any climate. Now, I wanted to ask about the simulation, the building simulation. Which tool do you use for that? And is it open, an open tool? Thank you.
Can I answer to that, Katerina?
Yes, yes, of course.
Just to say that each pilot city that participated in Impulse used different tools, depending on what is more frequently used or what was the availability of tools to be used by each pilot city. In our case, in Greece, we use a dynamic simulation tool, which is a commercial tool. It is not freely available. It's available on a, based on a license. But as Katerina explained earlier, one can do simulations using a more simplified tools that are freely available to all, or even taking results from energy performance certificates or from bills, etc. If if you don't want to do the full simulation. Obviously, the more sophisticated tools have higher chances of giving more accurate representation of the results. In our case, we used a specific commercial software to undertake the simulations.
Okay, thank you.
And also regarding the climatic zones, I would like to just add that in the current project that we are running, the Efficient Buildings project, which I spoke about earlier, which is the horizontal project, the follow-up of the previous MEDNIS project, where the aim was to capitalize on all these results of Impulse, but also of all the other 9 modular MED projects on energy efficiency in buildings. We are undertaking some work in terms of some adaptations that can be done to the already developed tools. And one of these adaptations, in this case specifically, is the adaptation to other climatic zones. So we are currently in the process of doing some work to work out if some correction factors or some simplified method can be applied without undertaking full simulations again for a different climatic zone, but to apply if you already have results. For example, we have results already for 10 simulated ambassador buildings for the municipality of Heraklion. And in the north of Greece, which is the climatic zone A in Greece, which is the hottest climatic zone in terms of temperatures. But in the north of Greece, where it is a different climatic zone with a lot colder temperatures, you may have similar buildings, similar school buildings, for example, of similar construction characteristics and years. And the only thing that differs is the climatic zone So we are trying to see if there is a quite a simple method that can be applied to transfer results to a different climatic zone. In cases where there is not the time or resources to run again all the simulations for the buildings of a different climatic zone. So we are currently working on this, and if any useful results come out of this exercise, they will be, of course, available on the project website as well.
Thank you very much, Eleni.
Thank you very much. Is there another question that we wish to have for either Ms. Pakianaki or even Ms. Hadjiorgiou regarding the outputs that they have already presented for the IPOS project? No, I don't think there is a question at this time. I think if you are all agreeable, we should have, since we are ahead of schedule, but we are already 2 hours into this training session, we should have a short break for 15 minutes and then come back to the final presentation about the Impulse Financial Scheme. If there is any objection about this, let me know. Okay, so thank you very much, Ms. Pakianaki and Ms. Hadjiorgiou. We will be having a short break and then we will be back in 15 minutes. For us, it's 12:20 CET to continue with our today's session about the Impulse Financial Scheme. Thank you very much.
See you shortly.
So welcome back, everyone. I hope everyone that was in the previous session has joined us again. After the short break, we shall continue with Dr. Ilya Mark. I don't know if I'm pronouncing it correctly, from Energy Institute Jorge Posar. And he's going to present to us the Impulse Financial Scheme that is an outcome that was selected for our SEACAP for SDG project. Dr. Mark, the floor is yours. I'm so sorry if I'm butchering your name.
No, it's okay, but it's just not doctor, it's just Mr. So
okay.
it's
Okay.
but pronouncement was pretty okay. I know it's very difficult for foreigners to pronounce our Slavic name correctly. It's Ilya Drmac.
Okay.
Okay, should I?
Yes, if you will, you can share your screen now. Thank you.
Okay, can you see the first slide?
We can see the first slide. We don't see it full screen yet.
Okay. Okay, first of all, thank you for having me, and it's really nice to have an opportunity to discuss about our past projects and past outcomes, and especially to see them live again. Thanks to George and Katarina for this, and Vera, of course, for this great introduction and great explanation of all the things that we have done. And I will here present basically 2 tools that were designed and implemented in Project Impulse. One is plugin tool, the multi-criteria tool for plan of refurbishment of public buildings in cities that were done in 6, I believe, pilots. We were responsible in age for city of Osijek and partly for city of Mostar, where we were also part of technical partner since the city of Mostar was a standalone partner. So the first step for identification of the path for greater implementation of efficiency measures, which is basically the most important thing, that we implement these measures at the local level, is to determine local level needs. So what we have learned from the project is that they need a systematic methodology for data collection and organization of buildings owned by a local community, ready to use indicators of energy efficiency of buildings owned by a local community, and of course, if possible, ready to use feasibility studies with proposed technologies and associated indicators of cost of and energy facilities. It would be nice that we heard that they could have a map of renovation so that they can visualize where the renovation is happening, and to monitor and to map the energy efficiency of public buildings in general. In close collaboration with the local authorities, we also discovered some weaknesses of the local level authorities. Weak inner structure of technical service in local level administration is one of them, and the others are low level of technical knowledge, which was expected, and the absence of the long-term strategy for sustainable development, which we basically saw as main weaknesses, and that's why the project at the end was funded and come alive in so many pilot locations. Also, inadequate budget for financing EE measures on local level is one of the key obstacles that were on this path for let's say implementation of refurbishment plan. So what we did is that we developed a multi-criteria tool for definition of yearly renovation plan for public building in local level. And as I said before, we were a technical partner and provided technical expertise and knowledge in project, especially in implementation of city of Osijek and Mostar. Other important tool, which is not here to presume to be presented, is also a GIS presentation of results, which we believe that helped and provided the project a good visibility for other non-partner cities of the project. So what is the plugin tool? First, you saw what all necessary steps led to a final document where we had all indicators, cost, energy, and environment indicators for all buildings. From the step one, where we had classification of public building typologies, to then the process of investigating what ambassador building should be representing these typologies, detailed energy audit and energy consumption balance done with the ambassador building, and of course then replication of all results to other buildings in typology and at the end in total stock of buildings owned by public authority. So at the end, all public buildings have defined the indicators and total values for energy, environment, and finance, and for refurbishment scenario. That was, I believe, 7 years ago when we started, and now it's a little bit different in Croatia. I will just share some of our experience. When we discussed and implemented this project, the goal was to have 4 different scenarios and maybe some sub scenarios, so that we can provide the end user many opportunities to see how they will go on with the refurbishment plan. Today in Croatia, there is only one available scenario, because we can only do refurbishment, total refurbishment of the building on the level of nearly zero energy building. So that changed a little bit, but I believe that it's not all in other states. This is just our experience. I will at the beginning first show and explain the tool on the presentation, and if you don't mind, afterwards I will present the tool itself and how it works. So as Katerina explained, we have around 50 different kinds of indicators, from annual electricity savings, consumption, special environmental, energy, and cost indicators. Idea was that the end user can choose up to 5 different indicators. As you can see here in this slide, on your left side, there are 5 different indicators. To explain a little bit more, only one step before, for each indicator, we proceeded with normalization of the value. So each value of indicator was normalized between 0 and 1. The 1 is the lowest number of the possible KPI, and the highest number of the possible KPI is 1. All between values, normalized value between 0 and 1. In some cases, there is also possibility that you can have maximum value as 0 and a minimum as 1, but it depends of the indicator. So you choose up to 5 indicators, and then you give them a weight factor in which you are basically saying what kind of refurbishment plan are you going to have. Is it going to be more focused on cost? In this case, you will have only economic indicators, or you want to have more focus on the CO2 reduction or energy consumption reduction. It depends. You have 50 indicators, different kinds, and you can choose whatever you think it's appropriate for your local authority. Also, we gave the position to favorite some options. For example, if public building typology 1 is somehow in your highest interest in the beginning, then you can favorize it with penalization up to plus 30%. If it's not on the top of your list, then you can give the lower penalization. In that case, this typology will be decreased for total mark will be decreased by 30%. Also, retrofit type of retrofit you can penalize, and renewable energy sources. So any scenario where we have renewable energy sources, regarding that, the mark will be penalization plus minus 30%. In the table below, you can see what kind of range of your plan will be. So you can hear, you don't see it, okay. Here on the left, you have different typologies. So you can choose what kind of typologies and what kind of retrofit scenarios do you want to be, do you include in plan? Oh, sorry. When you decide everything that is presented here, then on the other sheet you can choose in the red cells, in the yellow cells, you can choose what relative retrofit area are you going to retrofit annually. 3% is something that goes with the EU legislative for many years ago, and that's why this number is here. Also, there is also one other possibility, which could be changed by the end user. As you can see on the left corner, there's a combination mark green cell, and below are the relative numbers for area of refurbishment. If you say that deep refurbishment means that you are going to refurbish all elements of the building, then you can, according to the scenario that you have planned for major or medium or minor, you can choose what kind of percentage of total area would be taken by this scenario retrofit. Here, according to ours, we decided on these percentages, but also this could be something to discuss or to see for the end user if he is going to change it or not. The final result is the annual plan, where you defined for each year what buildings are you going to retrofit and according to which scenario. Here you can see the floor area retrofitted by yearly plan, annual investment in national currency, and savings in currency, CO2 emission, and kilowatt hour per year. Also, there is a possibility of graphical representation of results, and you can see how much some indicator are influencing the total mark of the building. Another one thing is that what we saw as a positive aspect is we enable end user to plan and monitor renovation of public building sector, to have a visualization of results. There is a good possibility, and we expect that we were expecting that this tool can be one way of solving the problem of planning for refurbishment of public buildings for necessary for development of SEACAP. Earlier it was the SEAP, validation and verification of implemented energy efficiency measures. But also we think that now if you don't have this kind of plan, if you are not making this plan as an official, then it's very possible that building refurbishment will not go according to the plan. It will not be yearly updated, which we think it's necessary to have it if you are going to have it as a working plan. So specifically for the city of Mostar, we planned actions such as to replan the refurbishment plan of building according to new situation on site. It's been 7 years ago, 5, I don't know, and integrate new plan in the SEACAP that was under development at the moment. This summer, I believe that we discussed that they had SEACAP in development phase. The other tool that was also developed by partners in the Impulse project was Impulse financial schemes, and which after you get the renovation plan according to the plugin tool, then you have possibility to plan your financial to make a financial plan according to the plan of multi-criteria tool. The two different scenarios were investigated here. One is taking one loan at the beginning for whole time of refurbishment plan, and the other one was one loan per year over the duration of renovation plan. I will go briefly through the introduction of the tool for financial scheme. First, you will see the yellow cells where you will input annual total energy related operational cost. That's something that is the beginning for planning of the financial plan. The other one is from the renovation plan, where you need to insert the cells that taking into account floor area retrofitted, annual investment, and savings in national currency. Also, you need to insert or copy the cells from plugin tool related to energy savings. The other important information that you need to insert in this tool are also expected interest rate of loan, energy discount rate, inflation for national currency, annual increase of public body budget, loan duration, annual increase of loan rate. For your financial information, you would need to think about other sources for financing, such as European subsidies, national subsidies, regional subsidies, and predict some amount that you are hoping to get from other sources than financial bank. So we have two different scenarios. One loan and at the beginning for total amount, and the second is each year one loan. Okay, this is the presentation of financial scheme, how it looks, the tool. You can see that if you financing with complete loan over 20 years, you can see the amount, total amount of your expenses, and you can see the that in the beginning, of course, the capital and interest are in first 5, 6, 7 years ago pretty dominant, and you can see that the energy bills are very small in the beginning because you already start implementation, and the higher cost is the cost of the loan. In the other scenario, where you are taking one loan per year, you can see that energy consumption bills are the majority, while the capital and interest are lower and lower. And throughout the years, you can see how the ratio between capital, interest, and energy bill are changing throughout the years. As you can see, here is a little bit different, where we have in the beginning, and if you have during the whole time of duration, it's a little bit also different. Here you can see on the comparison how it looks if we have according to the energy bill baseline, how the financing should go on from one loan at the beginning till or 1 year, one loan per year. In cumulative, the presentation looks like this over 40 years. So I think the best now would be to present a tool in live to see to just to show you how the things were happening when you are using it. Katarina and Vera explained that it's applicable everywhere. I mean, I will give you just one example. We reused this tool in 2 projects in Croatia. First one was for one county, where we made the same plan for energy refurbishment plan for county of northeast part of Croatia, And the other one was where we used this tool for railway station and for railway company in Croatia for their strategy for refurbishment of the stations, railway stations. We took into consideration 50 different buildings with different climate conditions. I think that it was greatly explained by all before me that in this case, climate conditions are taken into account when doing energy modeling for Ambassador. So in this case, when you modeling other buildings according to Ambassador buildings, for all necessary climate conditions are taken into account. Okay, so are you seeing my Excel file or still?
We're still seeing the presentation.
Okay, just a second. You already saw file D341 explained by, I believe, Katarina.
Now we can see the exam. No.
Okay.
For a few seconds we
Yes,
could
yes,
see,
yes.
but now
It was. I think now it should be okay.
yes, now
So,
we can see it.
The important thing is that here you have in this cell DEF1, you see the red one, the 341 KPIs most starting. It's very important to have open, if you're working with plugin, it's very important that both files are open at the same time, plugin tool and D341. Also a very important thing is that the name of the file, which is open, D341, is the same titled here. So, okay, I will present you now three types of, three different approaches, let's say, for planning of refurbishment. Let's go. First, we will say we are interested only in energy. So what we are going to say is that my main KPI will be total primer energy consumption. I'm also very interested in, let's say, annual electricity consumption, of course, and fossil fuels. But let's say that I'm more interested in KPI that will tell me annual savings of fossil fuel consumption per square meter per year. And also, I want to see what's happening with my renewable energy and also like this. And I will put the factors, let's say, like this. You see, if it goes above 100, then the tool automatically gives you a message that sum of weight factors must be 100. So we need to reduce one. Now it's okay. Let's say that I don't want to prioritize anything and I want to include all buildings and all scenarios. So my chart would look like this. This means that some buildings, as you can see here, this is typology. Well, I cannot see the typology exact, but I believe it's somewhere around 40 number. You can see how each indicator reflects on the total score and what kind of energy indicators and total results are presented. As expected, the most energy consuming scenarios are related to deep retrofit. That's why we have the highest results regarding deep retrofit. Also, we have major and some minor retrofit, which is a little bit for me new, but it could be that according, let's see what kind of indicators that we chosen. I believe that we have selected annual generation of renewable. Oh, we have the same one twice. Okay, it doesn't affect very much because it's just 20%. However, if we say, I want to look at just financially, I'm interested only in financial results, and let's say only payback period, and let's give them 100. So I'm interested only in the scenarios that will give me my money as fast as possible back. You see the list, and the graphical presentation also presents the expected results. The minor retrofit, which mainly consists of changing the lighting, which is very good for payback period, and simple interventions in HVAC without any major investments planned for this kind of scenario. And expected results are also according to our selected KPIs. We can see that expected results are also on the graphical presentation. However, if you want to say, okay, I'm only interested in, let's say, total annual avoided CO2 emission, and we can see how will this reflect on our current plan. Majority of good higher marks are related to deep and major retrofit.
Excuse me, sorry to interrupt you, but it is maybe important. If you can give us here in the x-axis, for example, for the minor retrofit or for medium retrofit, etc. What is the variable here?
Okay, all variables are. You don't. Okay, oh, just a second. Okay, all variables are inside D341 KPIs Excel file that was presented earlier, and you can see them here listed for each city and for each KPI, environmental, ecological, etc. So we have projection based, minor retrofit, medium retrofit, major retrofit. What is interesting is maybe that for minor retrofit, let's see if you are interested in description. I don't know, description is not here. Medium retrofit. So you have a description of each measure and how it reflects on energy consumption and also at the end on KPIs. So all data are here in D341. Ambassador and ambassadors the same value of ambassador according to specific area are the same for each building in the topology.
Yes, thank you. But still, my question was about, for example, if you return back to the graph, please.
Okay.
If you return back to the graph
okay.
For example, we can see overall score and on the y-axis, but when we go to the x-axis, is it the BBT1, BBT2, BB3 that make this change over when we go through the x-axis?
Okay, you can see.
Yeah, here, for example, minor retrofit. If you look at minor retrofit, yes.
Yeah, you cannot see it here. You cannot see it here, but you can see it here. Here is the list.
Okay.
As you can see, elementary school.
All right. So these are
major retrofit, minor retrofit.
Okay. All right. All right. Thank you. Thank you. It is clear. All right.
Okay. And if you want to check out now the result is this yearly plan. So you have floor area retrofit, you have annual investment and savings according to currency, CO2 and energy. You take these three and this fourth line and I will now open a financial tool. You copied it in the sheet hypothesis. Here you can see in these yellow cells, floor area retrofit, annual savings, savings in national currency, and savings in kilowatt hour. Also here in hypothesis, you put the total energy bill in national currency, the cost for annual cost of energy for whole building stock. Here you can choose different kinds of interest rates, energy discount rates, inflation, all other financial elements that can help you to make your financial plan for implementation of refurbishment plan. The other thing is that you can also have you have a possibility to insert some European subsidies, national subsidies, maybe some regional subsidies or whatever kind of subsidies that you can get that can help you to plan your financial plan for this. This is what it's considered regarding hypothesis. And then we have two calculations. One, as you can see, presented here, one loan at the beginning of the project implementation and for the whole duration and for whole duration. And the other one loan per year regarding planned investment according to the plugin tool. To summarize, this was regarding the two tools developed in Impulse. I think I really enjoyed working with all partners, and this tool is still alive. As I already explained, we use it in two different projects in Croatia. There is also possibility, I mean, you have to take, before taking this plugin tool in consideration, if you are going to use it somewhere else, have in mind that there are two possible scenarios. One is that you are coming from a state where you have good input data related to buildings owned by a local community or company or whatever. But at the end that you know how buildings, in what state they are, what kind of installation do you have on site, what is the envelope situation. It could be great that you have developed for all of them energy audits. In this case, you maybe don't need all the steps presented here. Maybe you can do it just to insert all data that you have from the buildings into the base case scenario, and then the other scenario according to energy audit. In this case, you don't need typologies. But if you are coming from the local community where you don't know a lot about your buildings, I mean, we saw it in many situations where you have insufficient data about the building, then this type of making first typology, then ambassador, then replicating results is very good path for planning and at the end to implementing the refurbishment plan. That's it from me. If you have any questions, I'm free for discussion.
Hello, Mr. Ilja. Thank you very much for this very interesting tool. These looks like big efforts have been made for preparing these. My question to you maybe not related to the details of the tool, but maybe related to your experience with utilizing the tool. As you know, that the financial indicators of the energy saving projects could be different indicators like you explained in the sheet. But from your experience, real hand-on experience on energy saving projects, which variable or which parameter you think or parameters you think most relevant or most important or most practical to use to evaluate the energy saving projects?
Thank you very much for the question. It depends, I have to be honest. One of my favorite is one which is not in planned ecological, environmental energy and cost indicator is the total investment cost per total energy saved. What does it mean? What does it mean? It means in which measure will you have most value for the money? And in this case, if you are looking at the value for the money, we consider it total energy saved. So this is the indicator that I like the most. You see it will change, but it's very, I mean, it's combined energy with cost. Both parts are very important. You can, I mean, we can imagine that we all have electric cars and nearly zero energy houses, but this is not the truth. However, we don't want to drive a 40-year car. We want to be somewhere what's affordable for us, and in that manner, this KPI represents a lot. Also, I think that the important KPI should be the primary energy savings in primary energy. Let me see where it is. this one. So like this, maybe. In this manner, you tackle the energy and cost relatively okay. I also like to add, I mean, we have a lot of discussions, you know, when you come up with such a tool, then you present it to local, then they say, okay, can we see this? Can we see that? I don't know, maybe annual increase of renewable in percentage. Okay, like this. It will go a little bit further. If I could choose, I would choose this. This is not okay, this is primary. Sorry. I would choose total investment cost per total energy saved and total annual primary energy consumption. Basically, it means how it goes on a reduction of energy primary consumption. I mean, it's always up to end user, but this is my suggestion.
Yes, thank you very much. Thank you. If you can go also to the final plan, the final result sheet. Yes. So it is sounds interesting. So based on this, it gives you as a municipality which let's say a category of buildings to cover every year.
Yes.
So that,
for example, you can say, okay, I want to annually retrofit 1%. In this case, it will change like this, or you want 7%. Then you understand. If you go higher with higher number, you will have a lower plan duration. For example, here you have 14 years. In 14 years, you will refurbish everything. But if you say, okay, I will do it slowly, 1% per year, then the plan will go on to 20 years.
thank you, thank you.
No problem.
So I would like to ask a question on this. I am Dimitrios Ziritas from MES Energy. So in the last slide that you presented, the goal is to achieve the deep retrofit for every building, right? Or could it be that for some buildings? Okay, so in the end, all buildings have the deep retrofit. It couldn't be that for some of them it's not. I don't know. It doesn't make sense to go up to a deep retrofit.
Deep retrofit. It's just as let's say it's not very precise. We have now a situation where each new building, and it was 1.5 years and 2.5 years before. The same rule was for public buildings. You have to reach the nearly zero energy building standard. Sometimes it means that you need to lower your energy consumption very strong, and somewhere it means that you will use a lot of renewables. So it's calculation between of them. But the standard is, I don't know, 45 watt per square meter of primary energy or something like that. I'm not know by heart. It depends. If it's a public building, it's single standalone house, you know, the technical rules for this standard, nearly zero energy building standard, are related to primary energy consumption and associated type of building. But it's called nearly zero energy standard.
Yeah. But so in the end, in this tool, So it gives you a plan so that every building that you consider has the deep retrofit at the end of this period.
Exactly.
Okay, okay. Thank you very much.
Is there another question that we would like to have for Mr. Ilya? So I don't see a question at this time.
Thank you very much.
Thank you very much for your presentation and all your work that you have showcased today. I want to encourage all the participants to reach out to you and all today's trainers for more information if they wish to have it, either through the SEACAP for SDG partners or directly through you. Of course, if the participant is connected to a project partner, they should also let us know as well. Thank you all to all of you that participated today, either the trainers from Impulse Project and of course the SEACAP for SDG partners, their external experts, and the municipalities that wish today to be part of this training session. We are ahead of schedule, so if there is any question regarding this training session, we could also like to have it. But of course, all of you are free to contact us at a later date, either to have the material that we will be gathering, either for additional questions. So thank you very much.
Excuse me, how we can get the material?
Yes, if you are, I don't know, you are the external expert for the SEACAP for SDG, or you are part of the municipality?
Yes, we are an municipality.
Okay, after the training session, either this or at a later date in this week, as the session progresses, we will gather all the information and send to the SEACAP for SDG partners. So each partner will be responsible to give you the information.
Okay.
If you are,
so we'll contact our partner, Arab Academy here in Egypt.
Yes, so the SEACAP for SDG partner that corresponds with you.
Yes, thank you.
Thank you very much.
Yeah.
So this is from the University of Patras. Thank you very much. I don't know if Shuha for Medrec will also like to say a few words.
No, thank you very much, Panayota, for your coordination today, and thank you to all the for accepting our invitation and presenting their results. So for all the participants, as Panayota said, we encourage you also to assess the upcoming sessions on the results of other projects in the framework of Interreg Med or ENI CBC Med programs, which will be in the following days. Thank you.
Thank you very much. Goodbye, and thank you all for your collaboration.
Thank you.
Bye-bye. Bye-bye.
Have a good day.
Thank you. Bye.
You too.